Good morning. Myself, G. Nageshwar Rao, Associate Professor, Department of IT, Session of Technology and Engineering. Now, today, the session is regarding one of the subject course regarding design and analysis of algorithms. Under that, in Unit 4, we are dealing regarding backtracking. We will check out what do you mean by backtracking. Backtracking is algorithmic technique whose goal is to use brute force. Which is going to use brute force for the solution of the problem. Right. Second one, in this, we have to make it clear regarding backtracking is a problem solving algorithm technique that involves finding a solution incrementally. Okay, we will check out. Okay, how it is going to happen, we will check out incrementally by trying different options. Okay, and undoing them if they lead to a dead end. Just we will check out diagrammatically how it is happening. Now check out how it is going to work. The starting node from this will move to A. That means I am thinking that is a possible solution, but I didn't get it. Now I am moving to B. But whatever the optimal solution that I am thinking of, this was not happened. So I am going to backtrack to A. After backtracking to A, that means we went to A to B. So this is the dead end. I am unable to move further. Now I backtrack to A. Now I am going to check the solution in another direction. Okay, that I have checked for C. Now this also becomes a dead end. Now this is the solution whatever I want, I am unable to get that. Now moving to the next solution. Went to A, not possible. Traced back to A, went to C, this is not my optimal solution, traced back. Now again from here I am moving to D, that means here I am tracing back to A, that means I am thinking of A is not a feasible solution in this direction. Now I am moving to D, then from D to E. Now it is not possible, so I am tracking back. Okay. In the similar way, I am going to check out here also. This direction is not possible for me. In this direction it is not possible. This is not possible. Now I am checking in this one. D to E. I move to dead end. So trace back. Now I checked in another direction. It also didn't happen. Now probably I am giving the final solution. How it is going to happen? Now see in this direction already we have checked. I went to B. This is the dead end. So I traced back to A. Now A to C I try to move. This is the dead end. Now again I trace back to A, and in this direction this is not having any feasible solution. Now I am tracing back to another direction which is D. Okay, from D to E. Here it is not a feasible solution. Now I am tracing back from E to D back again. Now again D to F. Okay, now this is the dead end, so I am moving back to other direction, that is G. Now here I got it. That means of all the possible solutions, which is going to be accepted, I am going to check out probably a number of solutions you are going to have. Now we will check out how the final tree is going to happen. Now see, in this is the starting node IS. From there I have started from the left subtree. I went to C. Okay, I am checking for the solution. This is not happened, and I checked here, and this is the dead end. So I traced back to the previous node, and I am checking in the right direction. This is also not happening. Now I am tracing back to again to here. I am checking in another direction. This is not happening. Ultimately, if I am going to go in this direction somewhere, I got the final solution. So that is going to be accepted. That means I am exploring various solutions. If not, I am unable to move further. That is going to be called as the dead end, and I am going to go backtracking, and I am going to check for the total solution. Right. Now next one. So some of the examples regarding backtracking. One of the problem that we are going to use is going to be n-queens problem. What is n-queens problem? The n-queens problem is, if suppose I am having 3 queens, considering, for example, I have to make a board of 3 by 3. In this, if I want to keep the queens in my board, suppose I am placing Q1 at row 1 and column 1. The rule here is no queen has to be placed in the diagonal direction, no queen has to be placed in the first row, no queen has to be placed in the first column. That means what are the possible solutions? Maybe if I am going to keep Q2, that is going to be okay. Okay, these directions, that means as per the diagonal, as per the row and as per column, that is not going to be possible. This is being called as, what you can call as the queen's problem, right? Now we will check step by step. We are going to check if n is equal to 1. This case we are checking. That means I am going to have a board with 1 by 1. Now I am able to place, I have to place only one queen. The Q1 has been placed. This is okay. This is one of the feasible solution. That is right. If I am going to consider n is equal to 2, that means n is equal to 2. Now the board is going to have a 2 dimensions, that is 2 rows and 2 columns, that is 2 by 2. Now if I am going to place Q1 here, what is the rule? I have to not to place diagonally. That means this position is not possible. If I am going to check regarding the row wise, this position is not possible. Column wise, this position is not possible. So ultimately what you can say, this is not a feasible solution, which is, that is n equal to 2. Right. Now we will go for the next one, that is n equal to 3. As per our consideration, we are going to check out a board of 3 rows and 3 columns. Now we will check out how the backtracking is going to happen. Here we are going to get, if I am going to place Q1 here, I am unable to place as per the row, as per the column and as per the diagonal. So what the places, those are free, except that this is one place, this is another place. If suppose I am going to keep here Q2, I am going to keep there Q2. Now if I want to place Q3, we have to check the other solution. Q3 I am unable to keep in the first row, I am unable to keep in the second row. At this point of moment, it is the third row is okay. But if I am going to check column wise, this is not right. Okay, that means it is not possible. It is not possible as per the row wise. Now, if I am going to check in third row, okay, now there is feasibility, but I have to check as per the column wise also. So, as per column wise, here is not feasible, and here also it is not feasible. Why? Because in this column you are having Q1, in this column you are having Q2. Now, we will check, that means only one slot is clear, is this one. We will check. Is possible to do there. It is as per the diagonal, it is having, this is also not possible. Now, what you are going to do? You are going to trace back. Okay, what will trace back? Please check out. Now, Q2 I am not going to place here. Apart from this, what is the other place you are having? This is okay. If I am going to place Q2 here, now I am going to, that means at this point of moment, I have backtracked. Q2. Backtrack Q2. Now I am going to check again, is there any possibility for keeping Q3? So, as per row wise, not possible. This row, it is not possible. So, this row is okay at this point of moment, but if I am going to check for column wise, this column, not possible. This column also not possible. So, what is the other one you are having? This is the only one that it is free. Suppose if I want to place Q3 here, that is not possible. Why? Because this is diagonal to Q2. Okay. Now, I trace back to Q2. I had checked all the possible solutions with the Q2. It is not possible. Now, I am going to trace back to Q1. I am going to trace back to Q1. We will check out how that will happen. Now, again I am considering a 3 by 3. Previously Q1 is here. Now, that is not possible. Now, I backtracked Q1 to here. Now, where to place Q2? As per first row, it is not possible. Okay, and this position it is not possible. This position also it is not possible. Okay, here this is not possible. Why? Because this is diagonal to Q1. This is as per column wise. So, what the two possible places? These two are. Now, if I am going to place here Q2. Okay, now I am going to check back again. I am going to check back again. I am able to keep Q3. This row it is, sorry, this column it is not possible. This column it is not possible. These two rows are not possible. So, probably this is the only one you are having after checking row wise and column wise. Suppose if I want to keep Q3 here, it is not possible. Why? Because Q1 is diagonal to that. So, ultimately what you can say, this is not also possible solution. Okay, now we will check out for the next one. That means we checked n equal to 1, that is possible. For n equal to 2, it is not possible. For n equal to 3 also it is not possible. Now move for the next one. Now I am taking an example of a 4-pin problem. Okay, that means already what we considered previously, the chessboard is going to be of 4 by 4. Okay, now we will check out one by one how we are going to place these. Okay, the steps I am considering here, I have considered Q1 in first row, first column. Now I am going to check the feasibility for Q2. I am able to place here, that is, this is not touching row wise, column wise, or the diagonal wise. I am going to check other feasible solutions later. Now I placed Q1 here. This is one of the feasible solution. So Q2 I kept. Now after keeping Q1 and Q2, now I have to check for Q3. Right. Q1 is in the first row. So as per the first row, it is not possible. Q2 is here. Here it is not possible. So as per the row wise, what are the possibilities you are having? You may have for 3 or 4. Okay, now we will check out. As per the third row, is the feasibility is there. As per the column Q1, this is not possible. Here, if I want to keep here, this is diagonal to Q2, so this is not possible. In the column of Q2, this is not possible. And this is diagonal to Q2, this is not possible. That means the third row is not possible. Now I am going for the next one. Here see, if I am going to check this particular place, it is not possible. Why? Because this is Q1 is there in the first column. So is there any feasible place for here? Yes, that is there. Why? Because it is not touching Q1 or Q2, row wise, column wise, or the diagonal. Okay, we kept Q3. But how many queens we have to place here? As this is going to be a 4 queen problem, we have to place 4 queens, right? So we will check the feasibility for the 4 one. Okay, now if I want to place Q3 now, sorry, Q4 now, after placing Q3, now check out. If I want to place Q4, as per row wise, here it is not possible. That means no queen should be in the same row as Q1. This row is not possible. Why? Because in that row the Q2 is there. This row is also not possible. Why? Because Q3 is there. What are the further possible options? The possible options are going to be these 4. Okay, now we will check out. Here, no. Here it is not possible. Here it is not possible because Q3 is here, and here also it is not possible. So I am not having feasible solutions. If I am having same as Q1, I am going to place at the first column and first row. Now we will check out the other solution. Okay, this is one of the feasible solution. Now that means I am keeping Q1 in the first row and third column. Now we will check out the feasible solutions for Q2. I am able to place here. That means it is not touching for Q1 row wise or column wise or as per the diagonal. That means Q1 and Q2 are okay. Now I am going to check for Q3. If I am going to place here, this is not possible. Here, as per the diagonal of Q2, it is not possible. This position. Similarly, here also this is as per the column wise. This is free. That means I am able to place Q4 here. Sorry, Q3 here. I am able to place Q3 there. Now I am going to check for, is there any possibility for keeping Q4? Yes. As per the column wise, Q1, Q2, Q3 positions are okay. Now I am trying to place Q4. As per the column wise of Q2, it is not possible. Is it possible here? We will check out. Now see, for regarding if I am going to place Q4 here, this is not, no one is there in the column, no one is there in the row. So as per row and column, it is not having any issue. Now if I am going to check as per diagonal, this is the Q1's diagonal. So it is not touching Q4. Okay, regarding Q1. If I am going to go regarding Q2, this is the diagonal of Q2. Okay, no issue. If I am going to check regarding Q3, this is the diagonal or this is the diagonal. Okay, or I am writing for all the feasible. So nowhere it is touching regarding Q4. So Q4 is also possible. That means this is one of the possible solution for a 4-queen problem. A 4-queen problem, right? Fine. Now we will check out the state space solution for this. Now see, for this I have taken an empty board. Now I try to place Q1 here, what we discussed previously. Okay, after that we are having possibility of Q2 here. Okay, the other feasibility is going to be, you can place Q2 here. If I am going to place Q1 and Q2 here, I am able to place Q3 here. Like this I am going to get the total solution for the 4-queen problem. And the state space, if you are going to draw, that seems like this. This we are using depth first search, in the sense we are going to search as per the depth wise. So this is regarding one of the what are the various possible solutions we are tracing out regarding a 4-queens problem, right? Fine. Now the next one. We will check out some other problem regarding backtracking, that is sum of subsets. What do you mean by sum of subsets? If suppose I am having a set like this, 2, 3, 7, 6 and 4. 2, 3, 7, 6 and 4. Okay. Now I want to get a maximum sum of 10. Now I am going to check the possible solution for the combination of which and which element I am going to get sum of subset as 10. Probably if I am going to add 2 plus 3, 5, 5 plus 7, 12. So that is not possible. Or I am taking other combination, 2 plus 3, 3 plus 6, that is also not possible. 2 plus 3, that is 5, 5 plus 4, 9, that is not possible. Or we are going to check like this, 3 plus 7 is nothing but 10. This is one of the solution that we are going to get, the maximum sum is going to be 10. Or if I am going to make the combination of 6 plus 4, that is also going to be 10. So here the possible solutions are 3 plus 7 and 6 plus 4. So how we are going to do with the help of backtracking, we will check out. Now we will solve a problem regarding this. This is we have to make a state space tree for the given weights. Those are, the set is going to be the set is three, 4, 5 and 6. Okay, and the sum we have to get is 13. Okay, we will check out through backtracking how you get the solution. Now see, for this in each and every node we are going to consider an ordinate. Okay, the ordinate the first part you are going to say what is the what will the sum to be considered, comma, to be considered. I will give out what do you mean by considered and what do you mean by to be considered. If suppose if I am going to consider 3, now that my node is going to have like so 3, and what are remain 4 plus 5 plus 6. 4 plus 5 is 9, 9 plus 6 is 15. That means if I am going to consider W1, now this is my node having the ordinate, the considered sum is 3, the sum to be considered is going to be 15. Now we will write down as per the same. How will do it? Check out. Initially I am not considering any of the elements, that is 0. Now next one, if I am going to make the sum of the elements, that means to be considered, 3 plus 4 is 7, 7 plus 5 is 12, 12 plus 6 is 18. That means this is the starting node where I didn't consider anything. Now I will go in two directions. Here in this, either the first element I am considering, I will go in this way, or I am not considering the first element. If I am going to consider the first element, what is the first element? That is 3. So that is 3. What the sum to be considered? If I am going to subtract from 18, we are going to subtract 3. That is going to be 15. That means if I am going to consider the first element, that is 1, element 1. What is element 1? That is 3. So we got the sum as 3, and the sum to be considered is going to be 15. Next we will move to the next one. Now I am going to consider W is equal to 1. That means the second element I am trying to make out. What is the other possibility? I am not going to consider the W2. Okay, if I am going to consider W2, 3, the second element I am considering, that is 7, 3 plus 4 is 7, I am going to subtract from 15, so that is going to become 11. Now we are checking, is 7 is matching 13? No. Again we are going to move to the next level, that is I am considering W3 or I am not going to consider W3. If I am going to consider W3, what is the next element? The next element is 5. So that is 12. 7 plus 5 is 12. And what remains? That is 6. Okay, now again, what the sum to be done? That is 13. So it is not happened. Now I am going to go for the next solution also. That is W4 is equal to 1. W4 is equal to 1. Okay. Now if I am going to consider that, if I am going to add back in, how much that is going to become? That is 18, and to be considered is going to be 0. But this is not a feasible solution for me. Why? Because the sum, how much that should be? That is going to be 13. Suppose if I am going to consider with W4 is equal to 0, what is this? This is going to come as, I am not considering. Okay, so the same way it is going to come. Why? Because if I am going to come in this particular path, here I consider W1, W2, W3, and here now I am considering W4. So actually I have to get 13, but here how much I have got? 12. So this is also not feasible solution for me. Okay, now I will go, I am going to backtrack. So this is not feasible, this is also not feasible. So I am backtracking to this position. Now I am not considering W3, right? That means I have moved in particular direction, I am unable to get out, so I traced back to here, and this is also possible, traced back, and from here we have traced back to here. Now for W3 is equal to 0. That means I consider W1, I consider W2. So at that moment, what is the sum? The sum is 7. Okay, and what the remain is going to be? See, here you should be a bit careful. That means here see, if I am coming in this direction, W1 I am considering, W2 I am considering, W3 I am not going to consider in later on stages also. Okay, that means what the sum remained is going to be 6 only. Why? Because I considered W1, I considered W2, I didn't consider this one if I am coming this route. Okay, further also nowhere I am going to consider that. So the sum up to here you are having 7, and to be considered is going to be 6. Okay, now it is not. Again I will try to consider here W4. W4 is equal to 1. If I am going to consider that, okay, 7 plus how much remained? The fourth element, that is 6. That is W4 is equal to 1. Now if I am going to consider that 13 and 0. Okay, now I will consider this particular solution as one of the feasible solution for sum of subsets. If I am going to go in this direction, that is going to be 7 and 0. So this is not feasible solution for me. I am going to wind up. Okay, now I have backtracked to this one, I have backtracked to this one, now I have backtracked to this one. Now I am going to consider regarding WT is equal to 0. For WT is equal to 0, if I am going to do that, 3, okay, and 11. 3 means I am considering W1, I am not considering W2. So here the sum is 3, and later on also I am not going to consider 4. So the remainder is going to be 5 plus 6, that is going to be 11. Again, you are going to have W3 is equal to 1, W3 is equal to 0. Okay, if I am going to have W3 equal to 0, that means I am considering, 1, I am considering 5. So 3 plus 5 is how much? 8. And what remained? 6. I am not considering here W3 also, so it is going to be 3, and what remained is going to be 6. Okay, again, now I am going to consider here regarding W4 is equal to 1, W4 is equal to 0. Okay, here you are going to get W4 is equal to 1, 8 plus 6 is equal to how much? That is going to be 14, 0. So this is not the sum, so truncate it. This is going to be 3, 0. So this is not the feasible solution. Okay, like this we are going to move to the other solution where I am going to consider, where I am not going to consider W1. If I am not going to consider W1, that means 0. Apart from 0, what to be considered? That means first element I am not considering, I am going to consider these 3 elements. So 4 plus 5 is 9, 9 plus 6 is 15. Okay, again in this, I am going to consider again WT is equal to 1, WT is equal to 0. Now check out. As per the W2, if I am going to consider 0 plus, what is W2? That is 4. So 0 plus 4 is going to be 4. And what to be considered? That is going to be 5 plus 6, that is 11. If I am not going to consider W2, that means in this case I am not considering W1, 3 I am not considering, 4 also I am not considering. So what the remain are going to be? That is 0. Okay, because I am not considering, 5 plus 6 is going to be 11. Okay, again As for the next level, we are going to consider double 3 is equal to 1, double 3 is going to be 0. Now check out what will be the values. Now here the previous sum is 4. Now what we are considering, the double 3 is 5. So 4 plus 9 is, 4 plus 5 is 9. Okay, 9 comma, how much that is going to be? The remainder is going to be 6. The remainder is going to be 6. Okay, and if double 3 is going to be 0, then it is going to be 4. That means in this we consider only W2, that is 4. W3 also 0, and here you are going to get 6. Here you are going to get 6. Okay, and again we are going to extend this. W4 is equal to 1, W4 is equal to 0. If I am going to consider here, 9 plus 6 is how much? 15. Okay, and this is going to be 0. So it is not 13, so this is not possible. This is not possible. Now we will go for the other one. W4 is equal to 0, that is going to be 9 comma 0. So this is not the sum we need, so that is also not a feasible solution. Similarly, we are going to go for here also W4 is equal to 1, W4 is equal to 0. Okay, if I am going to consider here W4 is equal to 1, this is nothing but 10 comma 0, which is not feasible. This is 4 comma 0, this is also not feasible. Okay, so what the other direction you are having, this you have to consider. Similarly, W3 is equal to 1, W3 is equal to 0. Okay, so in this direction also we have to check out, is W3 is equal to 1. Okay, so here you are having 0, 0 plus 5 is going to be 5, what remained is going to be 6. Similarly, you have to check out here also, W4 is equal to 1 and W4 is equal to 0. If you are going to consider here, this is going to be 5 plus 6 is going to be 11, and this is going to be how much? 0. So this is not feasible solution, and this is also not feasible. Why? Because 5 and 0 not feasible. Okay, so similarly we are going to backtrack. Okay, this is going to be 0 comma, what is that? You are going to get 6. Okay, so this is not the feasible solution. W4 is equal to 1 and W4 is equal to 0. Okay, now this is going to be how much? W4 I am considering, so this is going to become 6 and 0. This is going to be 0 and 0. So which are not feasible solutions. So here we got only one feasible solution. What is that? This one. Now that means as a solution you are going to write down like so, is equal to the elements we are going to consider. That means in this direction, if you are going to check out, I am considering W1. Is it right? Yes, that is 1. Then we are not considering W2 also. W1 we consider, W2 we consider, we are not considering W3, that is 0, and we are considering W4, that is 1. So 1 1 0 1. 1 means I am considering 3. Again 1 means I am considering 4. I am not considering 5. I am considering 6. So 3 plus 4 plus 6 is going to be how much? 13. Okay, so this is one of the only one solution you got. Okay, this is regarding what is going to be sum of subsets. And thank you. If you are having any queries, you can mail me at nageshwara@cc.ac.in, or you can give a WhatsApp. That is, my WhatsApp number is 7013658295. Thank you. Thank you very much.